All right. Hello, everybody. This is Aaron from ACM Cyber at UC San Diego. This is a walkthrough of the educational challenge printFailed for SDCTF 2022. The challenge is originally from SDCTF 2021, but these educational challenges are just designed for you to just follow along with me, have fun, and get familiar with the tools and techniques used in each category. These educational challenges are not worth points, so if you're quote unquote big leagues, you don't need to waste your time on them. But for those beginner teams that do complete all of our educational challenges, you will not only learn a lot, but you will receive a very small, very special prize to commemorate your learning. So, yeah, this category, print failed, is from the pwn category of last year's CTF. That's why it's actually on the 2021 public repo. And here you're given a lot of information. You're given the original prompt, instructions on how to connect to the problem, um, information about what is attached along with this challenge, the original specification, the original flag. This flag is going to be different than the flag that you're going to turn in for points, so don't submit this flag. What you're going to want to do is follow along with me, and then you'll get a different flag that is then what you're going to want to submit for points. So as proof of you actually following along. And we also have a bunch of write-ups down here if my explanations are insufficient. It's always very useful to see how other people who are, by the way, much smarter than me, might have gone about solving this. So taking a look here, we read the prompt, right? That's probably the first thing we should do. I'm new to C. I just learned printf and everything just worked, TM. But my friend Greg, who works at a security company, tells me that some strings crashed the program, but refuses to tell me specifically which ones. He wants to publish those in DEF CON. Can you find the magic string before he carries out his evil plan? And you connect to this via netcat, as you will most pwn challenges, and it will allow you to interface with this binary that's running on this port on this server. Now, this will probably be the same URL you'll connect to. The one I'm connecting to is slightly different because I'm in development mode at the moment. So if I go in here and connect to it myself, I will get the same prompt that you're going to get. It just says, can you guess the scrambled flag? I'll just say no, and it'll say, you guessed no, wrong. And then if I hit enter again, it just boots me back out. I have to try again. So as you can see, I'm probably going to have a difficult time organically guessing what exactly this flag is. So let's take a look back at the prompt. We'll notice that we're given the print failed binary as an attachment, which I believe is in here. So if I go ahead and download that, I already have it downloaded, so I'm going to save you the time, and I'm also going to get rid of some of this core dump stuff that I haven't cleaned up from my own testing. This is the binary. And if we want to learn more about what this binary does, this isn't a reversing challenge technically, but there is a reversing element here of trying to figure out how this thing works internally. But because it's in the pwn category, we can expect that the reversing aspect of this challenge is not going to be insanely sophisticated. The most common tool that's going to be used to I guess, decompile a binary like this would be Ghidra. I'm too lazy to install Ghidra. I think I have Cutter at the moment, which is a similar type of tool. It's cross-platform and all that other stuff. And if I load this binary, we can go ahead and do, let's see here, probably just the default settings are fine. If we load this binary, it will do a lot of the same things that Ghidra will do for us, such as decompile it for me. In fact, actually, there's a decompiler setting for Ghidra decompilation, but this is the entry, not the main. So let's go to main, which is probably going to be where all the magic happens. And sure enough, it's actually pretty easy to read. It's a main function. We take in a bunch of variables. It looks like we open something. This is the file open call. This is probably the flag file. And then we... so we take in the input from the flag file. There's some kind of scramble function that mutates it somehow. We might want to look at that in a minute. And then a bunch of other stuff happens. And then basically we get some input from the user, which is this guess, right? This fgets we're getting from standard in. So this is the guess input, and it can take in 28, like the size of the input is 28. So because we're using this more secure fgets function, we're probably not going to be able to do like a full buffer overflow. And actually, based on the name that says print failed, we can probably guess that it has something to do with printf, which is a function that has a known vulnerability if you pass in, or a whole family of vulnerabilities, if you happen to pass in a user input into the format part of the string, right? So the way printf works, and you can look this up by Googling the specification for the printf function, but you take in a guess, or not a guess, a format string is your first parameter, and then everything else is like inputs. But this format string has a lot of power. You can do things like read variables off of the stack. But what's interesting about this invocation of printf is that we just straight up pass in a bunch of stuff, including the flag. We pass in the flag to this printf function. And because we have control over the format of this printf function, we can actually print this input using a correct format specifier. Let me see if I can demonstrate this by Googling the syntax for printf. This is the C++ reference. We can see here's all the different types of syntaxes that are supported. I tend to be able to parse this easier by looking at the examples, but you can see you can print a string that's passed as the second argument by just doing %s. I mean, let's just go ahead and try this stupid thing out. So if I pop this terminal back open and I connect back to the script, if I do $S to print a string, it doesn't print anything. Although I want to say that's because it's not passed as the first argument. It's passed as like the fourth argument. And we can actually specify that we want to fetch the fourth argument by doing this interesting like %for $S, which is basically saying get the fourth string that's passed in. When we do that, it spits out this variable that's contained in the flag slot, but it also tries to check to see if the input was equal to this, which of course it's not. So it'll say wrong. And what's funny is we can check to see if this really is the flag, or I guess I should say the scrambled flag, by reconnecting and just giving it this as the scrambled flag. And it's like, nice guess. That is the correct flag. Unfortunately, it is, again, scrambled. So we were able to exfiltrate the scrambled version of this flag, but we do want to find out what it actually is. So you'll notice it looks kind of like the flag format. The flag format we're used to is SDCTF, so 5 characters, and then a special character, like a curly brace, and then over here is another closing curly brace. And you can kind of see like there's quotes where we might expect like underscores. The point is, this looks like some kind of just a shift, and we can verify that by going back in a cutter and looking at the scramble function. When we look at the scramble function, we basically get that same idea, which is that we iterate over the argument that's passed in, and for each character, we shift it by 1. We add 1 to the ASCII value of that character. And so we can actually undo this using the extremely popular CyberChef tool. If we just put in the scrambled flag as our input, you might be tempted to do like the Caesar cipher shift type thing and just do like a shift of 1, or I guess in this case -1. And this will almost work, right? You get the letters out, but you don't get the symbols because it doesn't really understand, like the Caesar cipher isn't really defined necessarily on symbols, and basically things that aren't lowercase and uppercase and numbers. So what you really want to do here to treat each of these characters like ASCII and rotate those on the ASCII table is there's a cipher called the sub, I shouldn't say a cipher, but a mutation called subtraction that will subtract the value you give it from each one. So if I do 1, it'll subtract 1 from each character, and you're left with what appears to be the exact flag. And yes, this is the flag. You can compare it to what's here. Yours is going to be a little different. You're going to want to actually turn this in to get your points, but in this case, this is how we were able to solve this challenge. Now, one thing I will mention is that this isn't a whole lot like most pwn challenges. I'll admit, we're using this as an example because it was a challenge provided last year, but it's not really representative of how you would solve most pwn challenges. And so, for the sake of maybe giving you, by the way, if all you came here for was the flag, and you're done, feel free to stop the video now. You don't have to keep watching. But for those of you that are interested in maybe some of the techniques behind pwn challenges, let's take a look at how we might solve this in the context of how we might solve most pwn challenges. So, I mean, most pwn challenges you'll solve with some kind of framework, like pwn tools, for example, is the one for Python, and a lot of pwn challenges are solvable in with frameworks like pwn tools in Python. And actually, you're going to see that most of the actual write-ups that you see from people that obviously know a lot about what they're doing they're going to be using pwn tools. Here's the awesome one by the White Hat, where you can see, I believe that's exactly what he does. Yes, he uses pwn tools here. So I'm going to go ahead and show maybe how you would do that, and kind of explain it a little bit, and then we'll go ahead and call it there. But okay, let's see. I think I froze. There we go. Okay, so the first thing you would do is you would download it locally, the binary, and you can see that I have that. I have that printFailed binary, and I also created a file, flag.txt, that contains like a dummy flag. And the reason why I created this file is because it basically printFailed will segfault. It tries to open the file flag.txt, and if it doesn't find it, it'll just crash. So by creating a test file that we can verify, we can kind of see what its behavior is. And again, we could just call printFailed directly, although I need to do a ./ at the front of it. Sorry about the OS beeps, by the way. I realize that's probably getting picked up. And we get the same exact thing. So we can say yes, and it will just say you guessed wrong. Now, what we can do is I've actually written here a script in pwn tools to in Python using pwn tools to hopefully solve this challenge. The way it works is pretty easy. You just import pwn tools. It's a library that lets you interface with both processes and things up there in the cloud, so to speak, like the remote process that you netcat into. It will allow you to just kind of swap that out, and so you can basically hone your exploit locally on the local binary, and then when it's ready and working, you can just switch to pointing at the actual CTF hosted instance of it, and then you can run your exploit on that, and it should work the same. So really simple. Pwn tools gives us this process call that lets us basically create an input output like that we can call programmatically into this printFailed binary. We do receive line to receive the line that says, can you guess what the scrambled flag is? Then we send our payload, and then we receive another line. Well, I believe this is the one that says, like, I think this is just the new next line after that or whatever. And then this receives the actual printed flag that gets spit out by the printf statement. So yeah, once we have the response, what's nice about doing things programmatically is that we can, we're not restricted to just sending typable characters, right? So in a lot of pwn challenges, you're going to want to send just bytes, which might end up being like shellcode. And pwn tools has the sophistication to generate shellcode. While I won't be going over that in this short little video, you should definitely look into it if you're interested. And in addition, when you get your response back from the server, you can always perform mutations on that, such as now, instead of having to use CyberChef to rotate the characters, I can actually just do it straight here in Python. Just iterate over each character in the response, subtract one, convert back to a string, join it back together. And we can go ahead and verify that this pretty much just works. If I do Python 3 printFailed.py, it's going to hook into that process. It's going to print right. This is the response that gets spit out. Then this is after I've shifted it, and then this is some garbage characters because it technically reads in more than it's supposed to. But yeah, you get the idea. So there you go. Next up, I'm going to go ahead and try to point this at the production version. Okay, welcome back. I grabbed the URL that I needed because I couldn't remember it. And then, yeah, once you do that, all I did is change that one line from the locally running process to the remotely running one. Now I can do, I can just run the script like I always would, and it will go ahead and reveal not only the scrambled flag, but it will descramble it for me as well. So this is a very efficient way of going about things because you can always, basically change parts of your script while still doing a lot each attempt. Anyway, so get familiar with Pwn tools. It's a really good introductory way of getting familiar with how you might do some of the more advanced Pwn challenges. Read lots of write-ups that'll help you understand what kind of methodologies are used. Anyway, go ahead and turn in your flag for points. Thank you so much for watching. I wish you the best of luck with the rest of the CTF, and I hope you have a good one. Bye, everybody.